Hello, my name is Maria Miller from mathmammoth.com. In this lesson we're going to be comparing proportional relationships. And I have prepared just this one exercise here with multiple questions for us. Think about these questions yourself first, okay? Because you will get much more, you will learn much more out of this lesson if you do so. If you just listen and agree with me that, okay, yeah, this is how it goes. It's not as fruitful as if you pause the video now and try to answer these questions yourself. If you struggle and try and you don't actually find the answers, it's still beneficial because that makes you learn more and it makes your brain actually grow. You get smarter by trying, putting forth the effort and then learning, okay? Now, if you already know this stuff and it's kind of easy peasy, then your brain won't grow. But in the other case, if you first struggle, and then learn either by doing it yourself or by listening to me, then your brain actually grows. Okay? Alright, so now let's look at it. The distance that airplane 1 has covered over time is shown in the graph, and then airplane 2 travels at the speed of 660 kilometers per hour. Which airplane travels faster? We're given the speed of airplane 2. And to find the speed of airplane 1, we can read it from the graph. Okay, so many kilometers per hour. Over here, it might make sense to look at 1 hour of time, 60 minutes. And in 60 minutes, here at this point, airplane 1 has traveled 600 kilometers. So its speed is 600 kilometers per hour. Airplane 2 was 660 kilometers per hour. So airplane 2 travels faster. How much faster? 60 kilometers per hour faster. Then graph a line depicting the distance airplane 2 travels over time. Okay, to graph a line you need 2 points, and then you can draw it. One point is right here, 0, 0. And the other point, you could look at the 1 hour mark, for example. 1 hour, and then 660 kilometers in that time. Where's 660? Okay, the scaling here, if this is 120, then this is 60. So each unit is 60. So from 600 over here would be 660. So right there would be the point. And then draw a line like that. State the slope of both lines. Now, it's tempting to say that they are 600 and 660. But my horizontal axis here is not in hours, it's in minutes. So therefore, that's not going to be true. The slope is the same as the rate of change. For airplane 1, we can use this dot. This here, the change in the, y values, or if this is d values. This change is 600. And the change here in this horizontal direction is 60 minutes. So this is kilometers, this is minutes. And so that becomes just 10 kilometers per minute. And that was airplane 1. Airplane 2, we would have 660 kilometers per 60 minutes. So that's 11 kilometers per minute. Now write an equation for both lines. Since these are proportional relationships, it's of the form y equals mx. Actually, this is probably not x, but t and d, distance and time. So we get for airplane 1, d equals the 10 times d. And airplane 2 is d equals 11t. We just take the slopes, which are also the unit rates. And then lastly, how much quicker will the quicker airplane travel a distance of 100 kilometers? Alright, if I look at the graph, 100 kilometers is somewhere here. I cannot use the graph to do it. It's just this a little tiny amount of time, the time difference between those two graphs. It's like this horizontal line between the two graphs. But I cannot read it from there, it's too small. So I need to calculate. We can use these two equations. And we would find the time, how much time the airplane 1 takes and how much time the airplane 2 takes to travel 100 kilometers. Both of those separately. So the slower airplane, this one here, we just put the distance in place of d and solve for t. 100 divided by 10 is 10. This is now minutes. And then for the faster airplane, same thing. Now we divide by 11. 100 over 11 minutes. And this is 9.090909 minutes. Sorry. And so now we can see the difference. It's about 1 minute, right? Or if we round this to 9.1, then the difference is 0.9 minutes. It would make sense to give this in seconds, right? Instead of minute, we write here 60 seconds. 0.9 times 60, that's actually going to be the same as 9 times 6. It makes sense that we will get a number that's a little bit less than 60, 54. 54 seconds faster. Okay, we're all done now with this lesson. I hope it was helpful.